Before we start our activity today, let's go ahead and take 2 deep cleansing breaths. Remember, you're going to be smelling the flower and blowing out a candle. I'm going to invite the bell 4 times. And I think of my flower today, I'm going to choose a sunflower to breathe in. All right, you read it. Are you ready? Okay. Breathe in. Breathe out. Breathe in. Breathe out. Great job. Remember, the breath is so important to us. It really focuses us and gets us ready to accomplish many things. Maybe you have a really important question to ask someone. Maybe taking those 2 deep breaths will get you ready and your brain clear and focused for what you're going to ask. Or you have an assignment to do or a test to take. Taking those 2 deep breaths before you begin that assignment or take that test will have rational thought and clear thoughts for you, and you'll be so successful. So the breath is so important to us. Enjoy your activity today. Today we're going to talk about magnets, and an amazing book about magnets is called Magnets Push, Magnets Pull by David Adler. We have this book in our library. You know, magnets are so important to many of us, from listening to our music to high-speed transport for trains, our vacuum cleaners, roller coasters, our computers, compasses, even moving car parts. Magnets come in all shapes and sizes. Magnets with holes in them, to miniature magnets, to fun magnets to hold your art on the wall. You can even get your favorite picture and make it into a magnet. Some people use magnets to advertise. Here's a burger place and a library right here. Maybe magnets help you remember things. Here's a teacher magnet. Sometimes we use these to pick up staples or maybe some tacks that we dropped on the floor. This is a huge magnet. It came from a stereo speaker. We have long, round magnets. And we have magnets that also share where their north and south poles. Could you imagine a world without magnets? One fun activity you can do is find a magnet maybe from your refrigerator and take that magnet and explore things around you that might attract your magnet. What about your office chair? Or the chair you sit on to do work, or any part of the table that you work at. Search for things around you that attract magnets. There are certain metals that magnets are attracted to: iron, nickel, and cobalt. I have this really large magnet here, and I have a pretty big fork. I wonder if this magnet will pick up my fork. Let's try it. Ooh, no. But it's metal. But it's not the metal that the magnet is attracted to. This fork is not made from iron, nickel, or cobalt. That's really important to remember about magnets. For this activity, we're going to go fishing. I will need something to hold a magnet. Either you can tie a magnet with a string, or I have a pipe cleaner here, and I have a magnet with a hole. So I'm going to thread that pipe cleaner into the hole and twist it, and this is going to become my fishing pole. This is my pond. I'm going to place something in the pond, and I'm going to fish for it to see if it's magnetic. Does it have iron, nickel, or cobalt in the object? Let's see if this bell is magnetic. Yes, I can lift it. I'm going to take all magnetic items and place them in this bowl. I'm going to choose another item to fish for. Here's a cool looking rock. I'm going to go fishing. Oh goodness. Did not pick up. So that means that this rock does not contain iron, nickel, or cobalt. So I'm going to put it on this side. Let's do another one. Let's see, I have a penny. Ooh, penny is metal. I wonder if my magnet will pick up the metal penny. No. Even though it's metal, it doesn't contain the correct type of metal. It doesn't have iron, nickel, or cobalt, so I must put it on this side. Let's try this rock. It looks a little different. I'm going to go fishing. It lifted it up. This is called iron ore. It has iron in it. So just because it's a rock doesn't mean that it might not be magnetic. I want you to find items around your house. I want you to go fishing for those items, find out which are magnetic and which are not magnetic, and then come to a conclusion. Why did everything in here attract a magnet and why everything on this side did not? All magnets have two poles, a north pole and a south pole, and the opposite poles attract. So one way I like to remember that is to put north on one hand, south on the other, and place them together. North, south, attract. North, south, attract. Let's see the attraction of north and south on these two magnets. If I get this magnet really close to the other, it will pull this magnet towards it because it's attracted to it. I'm going to go really slow and see if it will pull the south to me and attract it. Did you see that? Let's pull it apart. I'm going to pull it. I'm going to just stop this. So north and south attract. But what about south-south? Well, those are opposites. So opposite, south-south, resist. South-south, resist. Same thing with north-north. Same poles resist. North-north, resist. North-north, resist. So let's see what happens when I try to push the south against the south pole. I'm just going to move this one. I didn't touch that one, but it moved backwards. Let's try it again. It's resisting. It does not want to attract. In fact, it repels. It pushes it away. Let's try north-north and see if the same thing happens because they're the same. So they're going to repel. They're resisting each other because they're the same pole. See if you can find two magnets and try out this phenomenon of opposites attract and same poles repel, resist. Did you know that magnets can travel through materials and still be magnetic? I bet you did. If you think about if you want a note on the refrigerator or a work of art on the refrigerator for it to stay, you just put a magnet on the work of art and the magnet goes through the work of art and attaches to your refrigerator. Well, let's test a couple of things to see how this works. I have a normal water bottle that's empty. I'm going to open it and I'm going to place some items that I know are magnetic inside of this empty bottle. I'm going to close the bottle, and the bottle is made of plastic. So can this magnet travel through this bottle? Let's see. Can it pick up any of these items and move them around? So it's going through the plastic. Let's make this harder. What if I put water in here? Would it still pick it up? That means the magnet would have to go through the plastic and water. Okay, I kept the items inside the bottle and it has water in it. Do you think the magnet will still pick up the items in the bottle? Let's see. Did it move it? It certainly did. So magnets can work through water also. Let's try another experiment of a magnet traveling through another material. This is a metal clipboard. It is not made out of iron, nickel, or cobalt. I can tell because when I pick up a magnet and place it on, the magnet doesn't stick. But watch what happens if I place my magnet here and another magnet behind it. I'll get my teacher magnet. Let's see if this magnet can travel through this clipboard. It can. It can move this around. Let's try something that's not a magnet. Let's say this bell. You could almost look like you're magic. You're not. You're a scientist who knows that magnets can travel through materials and you can move them. You should try this at home. Find a magnet, something that is magnetic, that's made of iron, nickel, or cobalt, and place it through an item and see if you can move it. Here is another fun magnetic activity, and people will think you're magic, but you're not. You're just a scientist. We're actually going to take something that's not magnetic, like a paper clip, and make it magnetic. Right now, if I tested it and I press this paper clip to another paper clip, it does not stick. So for this particular experiment, you'll need one magnet and at least 2 paper clips. See, the neat part about a magnet is that it can actually travel through items that either have iron, nickel, or cobalt and have it attract another. So I'm going to pick up this magnet and I'm going to place the paper clip down on the magnet, and I'm going to take another paper clip and place it beside it. I did not hook it in. It's just sitting there. Oh, it's even pulling it. Let's try that again. Uh-oh, it did hook. Let's unhook it and try that again. That's funny. Okay, not hooked. Let's try this paper clip, put it right there at the bottom, and it stayed. I wonder if I can do 3 chains. Oh, the magnetic is so strong that it's lifting the paper clips and attaching to the other side. Oh, how about that one? Oh, that one worked. Let's try that one more time. Let's see if we can get 3. We did it. The magnet is traveling through the paper clips. So your experiment is to see if you can make a paper clip chain using a magnet without hooking them together and see how long of a chain you can create. Now, if I used a tiny magnet, do you think that the paper clips will go together? Oh, you can tell that was magnetic there. Do you think that this paper clip will attach with this tiny magnet? And why not? This one worked. This is obviously magnetic, but it doesn't pull this one. Why do you think? And if this one could do 3 chains, how many do you think my speaker magnet would create? You try it. Most of our activities have been focused on the attraction of the magnet, of the North and the South Pole. This activity, we're going to do the resist, the repel, 2 of the same poles working against each other to create energy. On this particular activity, you'll need a car, 2 flat magnets, a pencil, some fast drying glue, or some really good tape. What we're going to do is we're going to tape the magnet to the pencil and the magnet to the car. But we've got to be really careful about which part we tape or glue. This is called a resist. So we're going to tape or glue our magnet at the end of the car, and we're going to glue the other magnet at the end of our pencil. Now, you want the sides that resist to go against each other. So if I place the magnets together, those are poles that attract, south and north. We do not want that. We want to do the opposite. We want to take one side so you feel the resist. So we're going to do a south-south or a north-north and glue those. And let's see what happens. For this activity, if you're using a fast-acting glue like super glue or a hot glue gun, you must have an adult assist you. If you're using tape, you can have them cut it, then you would place the tape behind the magnets. Okay, so I have a south pole and a south pole. Let's see what a resist and repel looks like. So the magnet is pushing my car away. It's not attracting the car, it's pushing against the poles of south-south or north-north. If your magnet attracts that magnet pretty quickly, that means that you didn't put the right pole. You didn't put same poles, you put opposite poles. You can try this at home. You can have races with your friends with multiple cars. Just make sure that you repel. Remember? Opposites attract. North, south, attract. North, south, attract. For this activity, it was the same poles. Same. South, south, resist. South, south, repel. Happy learning!